want to demonstrate that sometimes the choice of u is a little bit tricky. In this problem, I think it would be fairly natural to say, let's just choose the denominator and choose u equals 1 plus e to the x, and then du equals e to the x dx. That certainly seems reasonable, except that it's going to be very difficult to use this substitution to replace that e to the x over 2 dx on top. Some people might say, oh, well, e to the x over 2 is the square root of e to the x, which is true. So you say, well, square root of du equals square root of e to the x dx, which equals e to the x over 2 square root of dx, question mark, question mark, question mark. None of this works. This is just not going to be. This is not going to work. You can't have a square root of dx in your substitution, so this is not going to be the right approach. Let's do it the correct way. So this might be a little easier to do if you remembered the following fact. You might recall that the antiderivative of 1 plus x squared is equal to the arctangent of x, which means, of course, that there's no difference if I just change the variable. So du, the antiderivative of du over 1 plus u squared equals arctangent of u. We can use that fact to find a better substitution here. What I really want is for this e to the x to play the role of u squared. Well, if e to the x is going to be u squared, then that means that u itself has to be the square root of e to the x, which is e to the x to the 1/2, which is e to the x over 2. There we go. So we have u equals e to the x over 2. Now we're starting to get closer to that expression on top that we have to replace. And that gives us du is equal to, it's e to the x over 2, but by the chain rule I have to multiply by 1/2 because the derivative of x over 2 is 1/2. So there's our expression for du. And multiplying both sides by 2, I get 2 du equals e to the x over 2 dx. Now I see the expression in the top that I have to replace. So let's write it again. We have integral of e to the x over 2 dx over 1 plus e to the x is equal to the integral of 2 du over 1 plus u squared du. Okay, so now let me just rewrite this one more time. 2 times the integral of du over 1 plus u squared. That gives us 2 times the arctangent of u, which equals 2 times the arctangent of e to the x over 2 plus c. 2 lessons here. Number 1, that rule about choosing the denominator, it works in certain circumstances. It doesn't work in every circumstance. Second lesson, don't forget your antiderivatives. Don't forget your derivatives of the inverse trig functions. Inverse trig functions are very important. You should recognize this form, that the antiderivative of 1 over 1 plus x squared is arctangent of x. And by the way, I'll write the other one that you should pretty much reflexively know. You should know that the antiderivative of 1 minus x of du over the square root of 1 minus x squared is arcsine of x. So those are forms that you're generally going to want to look for and not ignore.